Welcome back. In this video I'm going to teach you some baby trigonometry, and you can feel very important and smart. It's not hard at all, but it is really important in physics. In physics, we're always interested in something called forces. A force is a push or a pull. So if you push a box, it's going to move. If you throw a ball, it's going to move. If you're on ice skates and you push into a wall, you're going to move. So all this movement is caused by forces, and a force is a push or a pull. The problem is a force can be pushed in any direction. So sometimes a force can be at right angles, can be straight up and down or straight sideways, but a lot of times it's not. A lot of times it's at an angle, and you're going to have to break that angle into its up-down components and its sideways components so that you know how much it is when you're adding them together. Okay, so bear with me. This seems like it's terrifying to start off with, but this is something that we're going to see over and over again, and it'll eventually get pretty easy with you. Okay, so I need to teach you a relationship in a right triangle. A right triangle has a 90-degree angle. That's why it's called a right triangle. You have the side that's across from the right angle, and that's called a hypotenuse. Okay, hypotenuse. And then you're going to have any angle that you're considering. We're just going to name it a Greek letter, theta. It's a TH, theta. So if I'm looking at this angle, then these two sides have a special relationship. If I look at this angle, I'll call it theta, and then these two sides would have the relationship. The opposite of the 90 is always called the hypotenuse. So for instance, if I'm looking at this angle, the side that's up across from it is called opposite. Okay, so it's opposite the angle of interest. Adjacent means beside, so the side beside the angle that I'm looking at is called adjacent. Now if I do another right triangle here, really ugly one, and here's the 90-degree angle, this is my hypotenuse. If I make this the angle of interest, the one I'm looking at, I'll call it theta. This is no longer the opposite. This is beside this angle, so this is now the adjacent because it's beside the angle of interest, and then across from the angle of interest is the opposite. Okay, so we have hypotenuse, opposite, and adjacent of an angle, and this is always a right triangle that we're going to look at right now. Now we have some relationships. The relationship is simply going to be a ratio. This length divided by this length is it has a relationship. This length divided by this length has a relationship. All of these right triangles are related. So if you make this bigger and bigger and bigger, the opposite's going to get bigger, but the adjacent's going to get bigger at the same proportion. The hypotenuse is getting bigger at the same proportion. So what you're going to see is that all right triangles are related in that it's not their sides that are always the same, but it's their ratios are always the same. So it doesn't matter what right triangle you have, you can end up with a ratio, which is a side divided by a side, or a side divided by a side, or a side divided by a side, whatever you're looking at, and we'll talk about each of these have special names. We're going to call the first relationship the sine of theta. Okay, the sine of this angle. Okay, the sine of this angle is the opposite over the hypotenuse. So if you take the opposite, which is a length, and divide by the hypotenuse, which is a length, you're going to get a fraction. And that fraction has a name, and we call it the sine of theta. That's all it is. It's just a relationship. Okay? So a different one we're going to call the cosine. The cosine of theta is going to be the adjacent divided by the hypotenuse. Okay? So this length divided by this length is always going to be a fraction, and that fraction has a special name. We call it the cosine of theta. Right? And then the last one that we're going to look at is the tangent of theta. All of these buttons are on your calculator, by the way. And the only ones we haven't used is the opposite and the adjacent. See, both of these have hypotenuses in it, and there's three sides. So we're going to say the tangent of theta is the relationship of the opposite to the adjacent. Okay, so sine is O over H, cosine is A over H, tangent is over A. I learned this in high school as Oscar had, so that's Oscar had, a hold on Arthur. So sine, cosine, tangent. If you learn it in that order, sine, cosine, tangent, it's Oscar had a hold on Arthur. Okay. There's some other ones, SOHCAHTOA. People have learned SOHCAHTOA to where all of these are in a special order. It doesn't matter. All you need to do is learn this relationship. Now, if I have an angle, okay, and I have a push, let's say that this is at 0 degrees and I'm pushing a ball, like I'm throwing a ball at an angle, or I'm launching it with a catapult or a cannon, and I actually have to hoist that cannon up to a certain angle, and I'm going to shoot it at that angle, okay? Let's imagine that this is throwing a baseball. You're throwing a baseball to third base or whatever. Some of this is an up-downness, okay? This much of this is an up-down component. This much of this is a sideways component. So what you can see is if I throw a ball, I'm making a force of a ball, okay? I've made a right triangle. Now look, I'm going to, since I've already looked at this as my angle, I'm just going to redraw this line. See, it's an up-down. I'm going to put it here, okay? And this one I'm just going to drop here so that I can use this angle because I already drew it. Okay, it's the same. These two triangles are identical. This is just cutting a sandwich in half. The sandwich sizes are exactly the same. This is the same as this. So I'm going to redraw it here. Here was my original. Here was straight up and down. Here is straight over. And the reason I redrew it is so that you could see that straight up and down and straight left and right is a 90-degree angle. So I've got a right triangle. And here is my hypotenuse. Hypotenuse is always opposite of the right angle. Okay, so here is the angle of interest, so I'm going to name it theta, just because I don't know why, just because. Okay, if this is the angle of interest, opposite is across, so I'll call that O, and adjacent is next door, so I'll call that A. So if I want to know, let's say that this is an angle, let's say theta is 45 degrees, could be anything. Okay, just guessed it. Okay, let's say it's an angle, and I want to know, and let's say that I'm pushing this at, let's say I'm throwing it at 10 meters per second. Okay, that's a force. 10 meters per second is how fast it's going. Let's say it has a velocity of 10 meters per second. How much of that velocity is going straight up, and how much of that velocity is going over? Okay, well, the straight up is O. The straight over is A. Okay? Now if you remember my relationships, sine is over H, cosine is A over H, and tangent is O over A. All right, now I know H because I've said that I've thrown it at 10 meters per second. That's a speed. So I know a number here. So I don't want to use O and A because then I won't use 10. I want to use my number. Okay? So anything that involves 10 is going to be O over H, okay, opposite over hypotenuse, that's sine of theta, or A over H, adjacent over hypotenuse, that's cosine of theta. So I could use either one, doesn't matter. I'm going to use the first one because it comes first. Okay, so I say the sine of theta, the sine of 45 degrees, because I know theta, because I said it was 45. The sine of 45 degrees is going to be opposite over H, but I know H is 10 meters per second. So I've got sine of 45 is 0, or opposite, over 10. Okay? Now the sine of 45 is a number, it's a fraction. So if you were to put 45 in your calculator, you would know what it is. You get an answer. And I'm going to solve for O. So I'm going to take 10 and I'm going to bring it up beside the sine of theta, and I'm going to have 10 times the sine of 45 equals O. Hold a second, I get my calculator. Thank you. Okay, I'm back. So if I were to take, I'll show you here, if I were to take 45 and push the sine button, I'm going to get, oh, this is backwards. I hate this calculator. Okay, let's say I take the sine of 45 degrees. Okay, and I get 0.707, and I multiply that by 10, and I get 7.07. Opposite here is going to be 7.07. That means if I throw something at 10 meters per second, the part that I'm throwing straight up in the air, if it's at 45 degrees, this amount is I'm going up in the air 7.07 meters per second. Okay. Now how fast am I throwing it sideways? So now I need an H, but I also need an A. Okay, I'm not interested in this because I need to know this, and I've got this. So I'm going to use cosine because of the relationship here. Cosine is adjacent over hypotenuse. So I'm going to say the cosine of 45 is adjacent over hypotenuse. Hypotenuse here is 10. So if I'm solving for A, I'm just going to get 10 out of the way. So I'm going to bring it up. 10 times the cosine of 45 degrees equals A. And you're going to see something neat because 45 is exactly a corner. And so you get a kind of a cool thing. So if I have the cosine of 45 degrees, I'm also going to get 0.707. It just happens that the sine of 45 and the cosine of 45 is exactly the same because these sides are the same. Okay, if you were to cut a square into half by the corner, these two sides will be identical. So that's what's happening here. Cosine and sine are the same. Multiply that by 10, and I have 7.07 equals A. 7.07. So what you're going to see is if I have a 45-degree angle here with a 10 meters per second speed or any kind of force, anything you want to look at, this is 7.07 meters per second straight up, and this is 7.07 meters per second across. Okay. Now you're probably sitting there with your jaws dropped. Welcome to high school. I'll help you. Okay. Thank you.